Hey, what's up, guys? This is Chung here again. So today, let's take a look at the latest biweekly contest problem, number 1654, minimum jumps to reach home. Right, a certain bug's home is on the axis at a position X. Okay, so your goal is to help them get to the X from position 0. So there's a rules, the bug can jumps. So it can jump either forward or backward. And you, it can jump either exactly A positions forward or B positions backward, and you cannot jump backward twice in a row. And that's one of the constraints here. And the second constraint is that there are some forbidden positions you cannot jump to. And it asks you to find the smallest jumps the box it needs to jump back to the home. And one more constraint is that you cannot jump to the negative integers, right? So just like this, right? You have a zero, you have 0 point, then you have x, and and there's like this bug, right? This bug can either jump forward or it can jump backwards, and you cannot jump to any of the negative locations. You can only jump from 0 to the maximum positions here. Okay, and then there are like some forbidden points here, right? So, and here are some examples, right? And then there are some constraints. So the constraints is like this, as you guys can see here. So it's like the longest it can jump is like 2000, right? And also the longest is either jumping backward or forward is also 2000. Okay, and it asks you to find the minimum number of jumps. Every time when you find the minimum numbers of jump, there are several options, right? So the first one is like the BFS. Actually, you should always think about BFS first, in my opinion. And then the second one is what is the DP, right? And the third one is the binary search. But obviously for this one, binary search will not work properly because the given like a number of jumps, you still need to find out how can you jump to that location, right? And the second one is the DP. So for DP, this one is a little bit tricky. So the reason being is that, um, since you can either jump forward or backwards, if you use a DP, you have two branches here. You either go forward and you go backwards, you will end up in the infinite loop very easily because you can either jump. Let's say we have a threshold for the longest place you can jump, right? You can either jump, you can now you jump to that location. You jump to this location, this X, and let's say the B is much bigger than A, right? And then you jump to this location, and then you jump back, right? Jump back to B, right, to somewhere here. This is B, and then you start over again. You jump a small steps by A until you reach here again, then you jump back. This is like an infinite loop. So basically, since this 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 problem is like for the current DP, you might go back to the previously position. No, not position, the previously state. So it's not a very good candidate for the DP problem. Then the only thing left is BFS, and BFS is exactly designed for this kind of problem, right? So, and for this problem, since we have some constraints here, right? So the state of a BFS is like it's two parameters. One is the current location. Second one is what? Second one is the if the last jump is a backward jump, is the last backward jump, and that's the two state for the BFS. Okay, so as long as you can figure out this part, then the rest is just to implement a BFS template. All right, let's do it then. Okay, so we have a queue here, so DQ, right? And then we have a initial state is 0 and false, right? So at the beginning, we start at 0 and the is last jump backwards is false. Okay. And then we have answer equals to 0, and then we have a scene, right, equals to set, sorry, and then scene dot add these things in it. All right. So that's that. And then we have a while loop, while q, right? For is in the range of the length of q. Okay. We do something, and then in the end we do an answer plus one. Okay. And then we return minus one if we never find the x during the BFI search, right? Cool. So that's that. All right. So now we have a current and is the last backward, right? I'll just use these two. Okay. Then I have this q dot pop left, right? So if the current is x, right, we simply return zero. Sorry, not we simply return the answer. Okay. Now it's the we jump forward, right? Mm, next position equals to the what? Current plus a. Okay. So we jump forward, we do some sanity check here. So first thing is that if the next position is not in the forbidden, right? Okay. Oh, and so since forbidden is a list, to make it faster, we just we can simply convert it to a set, right? Set forbidden. Okay. So that's that. And the next position, right? So this is the first condition. And second condition is that, for the furthest place we can jump, we have to figure out like a maximum value this bug can jump. Otherwise, if we don't set this like a value here, I mean, if the next position is smaller than something, right? If we don't set these conditions here, this bug can jump all the way to the maximum position, right? So we have to somehow stop it somewhere. And where should we stop it, right? I mean, we can set up like a pretty long numbers, and as you guys can see here, so x is the furthest it can go. It's the furthest home, right? And a and b is also 2000, which means that that's that's the longest the bug can jump at one time, right? So a safe number will be what? So 2000 2000 is the max, the x, right? Plus what? Plus the maximum of A or B should be safe. Basically, if this bug, let's say if this X right here, right, and let's say that the bug can jump to 2000 at most. If our current location is like 5000, right, which is greater than the 2000 plus 2000, right, then there's no point to keep jumping forward because that will definitely not give us a, a better result. We can just simply stop there and then we should go back, right? So that's why I'm simply use a 4000, or you can just use what? You can use the x plus max of a and b. I think this should also work, but I'm just using 4000 here, and of course, so that's that, and then yeah, and then the next position, right, and then the false, not in scene, right? So this false is pretty straightforward. This one means that it's a last jump backward. No, probably no, because we are jumping forward. And then I have q dot append next position, right? And then false. So, and don't forget to add these things to the end here, okay? To the scene here. So that's jump forward, right? And then now next one is jump backward, right? So jump backward, the first thing to check is that if not is last backward, right? So we check this one first. If that one is not the ones, we can just jump backward. So we do next position equals to current equals to the current minus subject B. So for these things, I'll just copy this one here. For this one, we instead of checking the furthest, we simply can check this, right? If this one is equal greater than 0, since we cannot jump to a negative location. So with these two constraints here, basically we are constraints this box within a manageable range. That's why it can give us the final answer. Okay, so and this one is true. That's all. This is also true, right? All right, cool. So that's it. All right, run the code. DQ. Oh, DQ. Oh, sorry, there's a typo here. All right, accept it. Run the code. Huh? Time limit exceeded. Interesting. While Q. Okay, jump forward if it's not in forbidden. So it's smaller. Oh, here. Oh, this thing is if should be within this if statement. Okay, that's why. Mm. All right, cool. So accept it. So I think it's one of the consequences if you simply do a copy and paste. So it's very easy to copy some unnecessary codes here. Yeah, so that's it, right? So it's basic, just like regular um, BFS templates, right? And yeah, so I mean the time and space complexity, right? I mean, so the time and space complexity is just like the number of states in our case, right? So how many states we have here? We have we have n here, right? So but let's say we have n here, and here since this one is O one, right? So the number of states is the n times times two, right? So yeah, because we have a n locations and each location has two states. That's why the total time complexity is two n is n, and space is also like O of n, right? Cool. Yeah, that's it for this problem. Okay, thank you so much for you guys to watch this video. Stay tuned. See you guys soon. Bye bye.